Hi, students. In this lecture, I am going to discuss vertical circular motion. And in this, we're having one is attaching a point mass to a massless spring. Second one to a massless rod. Okay. See now, first one attaching point mass to a massless rod. So here we want to calculate what minimum velocity we have to provide at the bottom. Let us take here string attached to so one end of the string fixed to the other end of the string attaching one point mass. So what minimum velocity we have to provide so that it is able to complete now vertical circular motion. Okay, like this. Okay. Now see first of all how tension depends on the position of the string. So to have circular motion, the first basic condition is string must be tight. So string is a tight means tension is a non-zero. Tension is non-zero. Let us take at one instant it makes angle theta with vertical. Now let us see free body diagram for that. Coming to free body diagram. mg vertically downwards. Tension along the string. Tension along the string. And let us take a speed of the particle at that instant is v. Speed is v. Okay. So since motion is now in circular path, we are taking components for mg. Tension is along the string. So we are taking components for weight mg along the string, normal to string. Okay. So it is now mg cos theta, and this is mg sin theta. Right. So mg sin theta is now along the tangent. That means if they ask question like what is a tangential force, then we can write tangential force is equal to mg sin theta. From this we can write tangential acceleration is g sin theta. Okay, right. Now focus along the string length. You can see this point mass following circular path. Therefore, there must be centripetal force. And see here who is providing centripetal force. So centripetal force means it is a net force towards the center. Here you can see tension is towards the center of the circle, and mg cos theta away from center. So net force towards center is it is a T minus mg cos theta. Net force towards center is T minus mg cos theta, which is known as centripetal force. That centripetal force equal to mv square by r. Okay. And see from this what we can write T equal to mg cos theta plus mv square by r. Tension equal to mg cos theta plus mv square by r. Here we can say that while it is moving up, while particle goes up, then speed will decrease. So here we are taking the particle and earth as a system. Then gravitational force becomes internal force and tension becomes external force. And by tension, no work is done because tension is always normal to velocity of the particle. That's why by tension, no work is done. That means on the system, by external force, no work is done. Therefore, we can conserve mechanical energy of the earth particle system. So while it is going up, its gravitational potential energy increases and kinetic energy decreases. That means speed is decreasing. Okay, so speed is decreasing, and while going up, you can see angle made by the string with vertical is increasing. So cos value increasing means, or theta value increasing means cos value is decreasing. That means when string becomes once again vertical, when string becomes once again vertical, then theta value 180 means tension is minimum. Tension is minimum at a highest point. Okay. And we told that it is the basic condition is tension must be non-zero. Okay. Right now, see carefully. We want to calculate minimum velocity that we have to provide at the bottom of the circuit. At the bottom of the circuit. So this U minimum we have to calculate. So condition one, when string becomes once again vertical, once again vertical, suppose velocity is v. Okay. Now, just now we discussed that tension is a minimum at a highest point. Okay. So what I'm saying is assume that tension is now zero when string becomes once again vertical. Okay. And see, because of this velocity, immediately it moves left side. So once it moves left side, again tension starts increasing. So here what I'm saying is we are taking now limiting case, that is when string becomes once again vertical, tension is zero. And because of this velocity, immediately what happens is tension starts increasing, means it is able to complete now vertical circle. So I'm taking a limiting case, that is tension equal to zero. When tension zero, now see forces acting on the particle. Forces that are acting on the particle. Tension zero. Now only one force acting, that is now mg, which is downwards. That means now mg provides centripetal force. Now mg provides centripetal force. Therefore, what I can do here, mg is equal to centripetal force equal to mass into acceleration v square by r. Okay, that implies v value root of rg, right? This is now speed at highest point. So we are moving at highest point to speed. Now we can find at lowest point to speed by using law of conservation of mechanical energy. So using that law of conservation of mechanical energy, see what we can write at highest point kinetic energy of m v square. It is rg. Let us take bottom as now reference level. Okay, this is now reference level, and this is a completely our choice. Okay, by taking this, height is now r plus r. It is 2r. So gravitational potential energy is now mgh. H value 2r. Okay. Now, when string comes to when one side string becomes vertical, that means when particle comes to the bottommost point, it is having only kinetic energy. because we have taken that as reference level. So only kinetic energy half mu square, where u is now minimum velocity that we have to provide. Now see from this what we get. Throughout mass gets cancelled. 2 2 so 4. 4 plus 1 5. That means u value, it is a root of 5 gr. So this is now minimum velocity that we have to provide at the bottommost point. So for this velocity at the highest point, tension becomes zero. Okay. So here we have to keep in mind one thing, we have to apply force equation to find tension. Second one, we have to apply energy equation to find the speed at one point. If we are knowing speed at some other point, that means in this we are using force equation and energy equation. Okay. So this is now minimum speed. Okay. Now take one simple problem to understand this concept. One based on this concept. For example, question is given like this. U value means at the bottom, velocity given is root of 10 gr. Question is at the bottom, velocity how much given? It is the root of 10 gr. Okay. Now question is find velocity when theta equal to 90 and theta equal to 180. Okay. Also find for those angles tension. Okay. So we are given velocity at the bottom, root 10 gr. We have to find velocity when angle is 90, angle is 180. Also we have to find tension. Now see what we are doing. To find velocity, we have to use a law of conservation of mechanical energy. Okay. So at the bottommost point, kinetic energy. So here no need to by heart any kind of formulas. At the bottommost point only kinetic energy. So it is a half mv square 10 gr. Okay. That is equal to angle 90 means string becomes a horizontal, right? Spring becomes a horizontal. That means height equal to how much? Height equal to r. So gravitational potential energy mgr. Remaining is now kinetic energy half mv square. This is now 2 gets cancelled. It is now 5 gr, 5 mgr minus mgr, 4 mgr, 4 mgr, that is equal to half mv square. So from this we can say v value root of 8gr, root of 8gr. Okay. If you want to find at 180 means see where change comes. Left side, no change. Right side height becomes 2r. This is 2 mgr. Okay. So 5 mgr minus 2 mgr, it is 3 mgr. 3 mgr, 3 into 2, 6. That means V value, see how much we get. See carefully, 2 here, 5 times, 5 mgr. This becomes 2r. Theta is 180. 5 minus 2, 3. 3 2 is 6. So V value root of 6gr. Means at the highest point velocity how much? Root of 6gr. So like this, using energy conservation, we can find velocity at any point. Right? So now we have to calculate tension. Okay. Now for tension, see what we have to do. See the equation here, T equal to mg cos theta plus mv square by r. Just put values in this. So when theta is 90, velocity root 8gr. I am writing here root 8gr. Okay. This becomes how much? 8 mg. Okay, no? Root 8gr means it is 8gr, 8 mg. Theta is 90. Cos 90 is 0. That means tension equal to 8 mg when theta is 90. When theta is 90. Next. When you are taking theta value 180, then see V value root 6gr. This is a 6 mg, right? 6 mg. And this is now minus mg. So tension how much? Tension equal to 5 mg. Tension equal to 5 mg when theta equal to 180. Like this, we can find tension and speed at any given instant. Okay, right. Let us now discuss in this some special cases like if velocity is not equal to root 5gr. Okay, we told that if velocity root 5gr, it is able to complete vertical circular motion or more than this. But if it is less than root 5gr, what happens? Okay, let us see that now. If it is less than root 5gr, right? Condition is now if it is less than root 5gr, what happens? Okay, right. First, we're taking the condition that if velocity equal to root 2gr, what happens? Velocity root 2gr, what happens? See carefully. First condition, if velocity, if u value root of 2gr, okay. So when we are giving velocity root of 2gr, it is able to complete circle only up to this level. Okay. That means string becomes a horizontal. Okay. String becomes horizontal. So at this instant, what happens is velocity becomes zero. Okay. Here velocity becomes zero. How we are saying that means by using energy conservation. See carefully once. Kinetic energy, how much? Kinetic energy equal to half mv square, 2gr. This is equal to mgr. This is a completely converting into potential energy. So height equal to r, right? So here velocity is zero. Since no velocity, tension how much? Tension. We have seen that tension equal to mg cos theta plus mv square by r. So here a v value 0, theta value 90 means the tension 0. So when string becomes horizontal, tension 0 and velocity also 0. Okay. So it follows a circular path. You can say it is semicircular path. Okay. Like this. Now next case which is very important, that is u value greater than root 2gr and less than root 5gr. Now see what happens. When velocity is greater than root 2gr, the particle enters into first quadrant. First, second, third, fourth. Okay. So here, motion confined to only third and fourth quadrants. If velocity greater than root 2gr but less than root 5gr, it enters into first quadrant but not able to complete circular motion. Okay. The reason is that before string becomes vertical, tension becomes zero. Means string slacks. String slacks means tension is zero. Once tension zero, circular motion is not possible. So to have circular motion, basic requirement is tension must be non-zero. Okay. Let us see now. Let us see now. At one point of time, string makes angle theta, theta with vertical. Okay. Its velocity along a tangent. Okay. Now see what happens. Condition one. The string becomes zero. Sorry, tension becomes zero. Okay. Tension becomes zero means how many forces acting here? Only mg acting downward side. Since tension becomes zero, only mg acting. Mg component provides now centripetal force. So I'm writing here first condition. First condition. First condition is mg, mg, mg cos theta providing centripetal force. So mg cos theta equal to mv square by r. One equation. Okay. In this, theta is not known. V also not known. Okay. We have two unknowns and we got here one equation. Second equation is energy equation. Okay. So I'm writing here by taking the bottom as reference level. Initially kinetic energy of m u square that is equal to present half m v square plus potential energy h value r plus r cos theta. See carefully once. This is r. Okay. Now this is how much correspond this one. This is now r cos theta. Okay. That is r cos theta. Right. Now simplify this. So here what we can do is in the place of mgr cos theta, I can write mgr cos theta, I can write mv square. Okay. So this becomes now half mv square plus mgr plus mgr plus mgr cos theta. mgr cos theta equal to mv square. Now this only unknown is now v, right? So from this see what we get v value. So that is equal to how much? P by 2 mv square plus mgr. Now simplify this, what we get? 3 by 2 mv square is equal to half mu square minus mgr. Okay. Minus mgr. Right, now simplify this, what we get? From that v square, that take v value. So V equal to root of U square minus 2GR by 3, right? Check once carefully. So here 2 are cancelled, 2 comes here. So U square minus 2GR, okay? Mass gets cancelled by 3. Okay. Now substitute this value in equation 1, okay? To get the value of cos theta. V square. In the place of that, substitute this value, V square. Okay. Here, mass gets cancelled, right? So cos theta equal to V square by GR. V square by GR. Cos theta equal to V square by GR. Means U square minus 2GR by GR means 3GR. Okay. This is a speed when tension becomes zero, and this is the corresponding angle. So angle made by string with upper vertical. Okay, right. So from this we can say that at what height, if they ask height, what is the height? R plus R cos theta. We got cos theta value, so height is known. And we got speed also. Therefore, we can find at what height string slacks. What is the angle made by string with upper vertical? If they ask with lower vertical, we have to take 180 minus theta, okay? Remaining how much? 180 minus theta. And if they ask speed, square root of u square minus 2gr by 3, okay? So like this, we can solve problems based on vertical circular motion. And next here, one more important point is, when tension becomes zero, now it will become say oblique projectile, because velocity makes some angle with a horizontal, right? So it follows now oblique projectile. That means we can ask like, what is maximum height from here? Okay. So any question basing on oblique projectile. So up to this position, circular motion, and after that it is oblique projectile. Okay. Right. Now see next one. In this what we have discussed. The first one, point mass attached to string which is massless. Next one, point mass attached to massless rod. It is massless rod. So it is also a very simple one. See where change comes, string and rod. Okay, string and rod. Coming to string, tension must be always zero. But coming to rod, since it is a rod, there is no question of becoming string becomes slack, but rod is. There is no question of rod becomes slack. Okay. Therefore, only condition is, suppose provide velocity u such that it is able to reach topmost point. So here velocity is zero. See carefully once again. Think in the reverse like this. It is a massless rod. Rod means there is no question of tension. Okay. Suppose rod is vertical like this. If you just push it, okay, just push it. Just pushing means velocity how much? Zero, almost. Then it follows circular path like this and again comes to same height because there is no energy loss. I am repeating, just push it from this position, it again comes to same position due to energy conservation. That means we have to provide velocity in such a way that rod is just able to become vertical. Okay. Now take energy conservation. Half mu square is equal to half m v square, where v value is 0, plus mgh. H value it is 2r. Okay, h value how much? It is 2r. Since v0, directly half m u square equal to mg into 2r. That means u value root of 4gr. Okay, root of 4gr. This is the minimum speed we have to provide at the bottom so that it is able to complete vertical circular motion, right? And here also we can find a speed at different points by using energy conservation like this, right?